So let's start with question number 3, which I found to be very interesting. Personally, I find geometry to be extremely interesting, and that's why I thought that there would be 2 problems here. I hope that there would be 2 problems here. But this is a completely non-routine geometry, and these kinds of construction problems or abstract problems, whichever way you say, are very beautiful in the sense that one of the most beautiful problems ever set in like INMO for with respect to geometry. Anyways, now I'll tell you the outline of the solution first. The question states that in case we have 3 points, then we can construct angle bisector, all possible 3 angle bisectors of this triangle. So I can construct this line, and this line. So I can construct all those lines. That means all the 3 lines are given to us that we can assume. And whenever we have 2 lines which intersect at a point, then I can construct this point as well. So I can assume that I have a new point which I can use in this question. The first thing I thought, can we draw a line between 2 points? Assuming this to be like a triangle with angle 0. But obviously the question says that x, y, z, 3 non-collinear points. Question says 3 non-collinear points, which implies I cannot assume 2 points to be same. So I cannot draw a line between any 2 points because that could have made my task easier. Now, so anyways, the question later says that we have to construct center of this triangle. Obviously, we start to think all the possible ideas that we know about center of a triangle, and then in center, and then angle bisector, all the possible things that are out there. The initial thought process that went for me was to construct all the 3 angle bisectors. Then maybe in center of these 3 triangles, using in center of these 3 triangles, maybe I can go for like twice of A angle, twice of B angle, and finding the center, that kind of point. I wanted to attack on 90 plus A by 2, which is angle BIC, right? Angle BIC is 90 plus A by 2, so I wanted to attack on that angle 90 plus A by 2 and somehow get to twice A. But getting from there to twice A using whatever method was not seeming possible. So I had to ditch that idea and try to something else. Now, obviously, the other idea that we can work here is perpendicular bisector. Now, perpendicular bisector of any segment, how we can work on that? Now, that is another idea which seems obvious after we know, but not so easy. In the sense that in case I have any point with respect to B and C, which is symmetric to BC, in the sense that this is isosceles triangle, then the angle bisector of this one with respect to BC will intersect here. That will form perpendicular bisector of this line. So in case we need this point, it's a different story, but if we need this line, we can always draw that. Such that if we can find perpendicular bisector of BC, perpendicular bisector of AC, and perpendicular bisector of AB, then we can get to the center of the triangle. Alright, so essentially what the question says is finding perpendicular bisector of BC. Alright, so what we have done here is, we have got to this point. What I'll do here is, in the next page, I'll show I'll show 2 important points. First point is this one. In case I can find a point with respect to BC, say this is point X, such that BX is equals to XC, then this angle bisector XT will be perpendicular bisector to BC. This is one important idea. Second idea here is this one. Now that is another very important idea and very interesting point. That even how to get to this point, how to get to this X point, right? Suppose we have 3 points are given to us. Suppose we have fourth point which is concyclic to A, B and C. So let this be A1. Then using this angle, then angle bisector of BAC and BA1C will meet at a point, say M. Angle bisector of BAC and angle bisector of BA1C will meet at a point M, which will be concyclic to ABC and which will also bisect this arc BC. Now, the solution might look easy after this one, but thinking to do this point was not that easy, in the sense that if we take angle bisector this one and this second angle bisector, name them as 1 and 2, if we try to imagine that, then we are not reaching at a point which by itself looks very important. Yes, that is reaching at a point which is concyclic to this one, but BM is equal to MC, we are not able to think at that particular time because there are too many thought processes going on. But what else can we do with angle bisector? Juggling through that, through half an hour, we get that if BM becomes MC, equal to MC, then the angle bisector of BMC will effectively be the perpendicular bisector of BC. Right? Once again, angle bisector of BMC will become perpendicular bisector of BC, and then we are done. That will give us perpendicular bisector of BC. Similarly, we can get perpendicular bisector of AC, and similarly, we can get perpendicular bisector of AB. Anyways, getting two perpendicular bisectors, we can get to the center. Alright? So, all we have to do here is, we have to find another point A1 which is concyclic to BAC. In case we find A1, we can find this angle bisector, construct M and do all the things that we want. Alright? So in this question, when we are given ABC, we have to find A1 which is concyclic to ABC and our work is done. Right? So 1, 2, now we'll move to the step 3, how to find that point A1. Once again, I'll start from here. We are given 3 points. I'm constructing the lines here, but obviously the lines are not given to us, or I would rather delete these lines. So let me start over with this point. So I'll start with A, B and C. Okay. These are 3 points given to us. I need to find a concyclic point with respect to A, B and C. A point which is concyclic to circumcircle of ABC. Alright. How do we do? Now that part is that part is very beautiful, in the sense that not so easy. The obvious thing that comes to mind is this one, that I and IA, let IA be the eccentre with respect to A. Midpoint of that lies on circumcircle. And therein some students have done mistake, in the sense that they have assumed that midpoint can be drawn. But obviously we had to go more beyond that. So that was an obvious step, in the sense that angle bisector in center we can always achieve. Let this be I. Eccentre we can always achieve. But how do we get to the midpoint of these two? Sorry, I told that eccentre we can achieve. Now that is also a difficult part. We'll see in time. In case we could have found IA, in center we can find, right? Because ABC is given, we can find two angle bisectors, and from there we can get I. Eccentre, we do not have any triangle. ABC is there, but BC and any other triangle is not there, such that we can find IA. So IA is not there. But in case we could have achieved IA, then BIC and IA, this becomes concyclic. And in case these 4 points are concyclic, we can find center of this BICIA, and center of this cyclic quadrilateral will be concyclic to ABC. But the difficult part is we cannot find IA so easily. So there are multiple solutions that can come there. Now one of the solution is this way, which Yadit is going to outline in some time. We'll take this triangle ABC. We'll take this AIC. Okay, this point is I. I'll use another color. All right. Now, say I take angle bisector of A, right? Say I take angle bisector of A. What I'm trying to do here is, I'm trying to find some point here which is concyclic to A, B and C, right? So I take this angle bisector. So we have taken angle bisector of A. What we are going to do here is, we are trying to find X center of AIC. We are going to find X center of triangle AIC. Okay? We'll see later on why are we doing that. Or I'll outline the solution after that also. Now what we are exactly going to do, we are trying to find perpendicular bisector of AI, perpendicular bisector of IC, perpendicular bisector of IB. Right? We are trying to find perpendicular bisectors of those. So anyways, say this point, which I'll name as say I1, is in center of AIC. On this AI, on this line AI, which I already have, I will take angle bisector of ICB. So angle bisector of ICB. So if I take this angle bisector, there is already angle bisector of, see, just one second. Yeah, so I'll find a point here. The importance of doing all these exercises, I was trying to find an external point on AI. I can always do that. So this XIC effectively represents external angle with respect to AIC. Alright, so I'll come again. I found this point X. Using this, what I will do is, I'll find angle bisector of XIC. Alright. I'll find angle bisector of AIC. And I already have angle bisector of AI1. Okay. So wherever they will intersect, say that point is I2, will form X center of AIC. So I1 is in center, I2 is X center of AIC. Using that, what we have here is that I1, C, I2 is concyclic. So we can find center of that, center of I1, C, I2, and from that center we can construct perpendicular bisector of IC. Once again, I'll show this point. IAC, I have found X by taking angle bisector of ICB. Now that I have found X, I can find angle bisector of XIC, which will act as external angle bisector of AIC. I already have internal angle bisector of IAC, which implies I can find this I2, which is exterior angle bisector of AIC. I can already find I1 and I1C, I2. These 4 points become concyclic, so I can find center of that. From there I can find perpendicular bisector of IC. So complicated problem, so beautiful problem. So what I was trying to say, that constructing solution of this one was very difficult, not so easy. And so many students, like at least 3-4 students that I know, they have covered this question in exam time completely. An extraordinary work actually. Because this is one of the better problems that I have seen in geometry otherwise. Anyways, coming back to this thing, if I can find perpendicular bisector of this one and this one, most of the work from here is done. Alright. So we found perpendicular bisector of AI, BI and CI. Why did we do that? I'll show you. I can find perpendicular bisector. From there, I can find this point U, which is center of AIC. And this is a well-known identity that if we have triangle ABC and say this is I, then center of BIC is this point which is concyclic to ABC. So that effectively U point is there. So if we get another point which is concyclic to ABC, our work is done. So there goes the complete solution of this question. So proud of Yajat, who actually completed this question in exam time. I call him here to present this solution. But as it turns out, it's a very extraordinary problem, a very nice problem. I really love this problem. All right.
नाउ इधर यूक्लिड है, वो कुछ टूल्स कर रहा है, उसके पास 3 पॉइंट्स है प्लेन में और हमको उसका सर्कमसेंटर ड्रॉ करना है. हम किसी भी 3 पॉइंट्स से उसके एंगल बाइसेक्टर बना सकते हैं. अगर ए बी सी है तो हम एंगल ए बी सी का एंगल बाइसेक्टर बना सकते हैं. इसके हेल्प से हमको सर्कमसेंटर पे जाना है फॉर एनी गिवन 3 पॉइंट्स. तो फिर अभी 3 पे डायरेक्ट जाना थोड़ा मुश्किल लगा तो हमने 4 पे जाने का सोचा कि 4 कॉन्साइक्लिक पॉइंट्स है, 4 कॉन्साइक्लिक पॉइंट्स. तो हम सेंटर क्या ड्रॉ कर सकते हैं. अगर 3 पे कर सकते हैं 4 पे तो करना ही चाहिए. तो 4 पे एक बार केस देख लेते हैं. मान लेते हैं कि ए बी सी डी 4 कॉन्साइक्लिक पॉइंट्स है. अब अगर हमको सर्कमसेंटर ड्रॉ करना है तो हमको काइंड ऑफ परपेंडिकुलर बाइसेक्टर्स बनाने हो गया. कोई भी परपेंडिकुलर बाइसेक्टर्स बना दिए, फॉर एग्जांपल ए बी का परपेंडिकुलर बाइसेक्टर बना दिया. सिमिलरली वी कैन ड्रॉ ए सी का परपेंडिकुलर बाइसेक्टर, वो इंटरसेक्ट करके सर्कमसेंटर पे बाय डेफिनेशन. और परपेंडिकुलर बाइसेक्टर बनाने के लिए हमको कोई भी ऐसा पॉइंट मिल गया. अगर हमको किसी लाइन का परपेंडिकुलर बाइसेक्टर बनाना है, मान ले सी डी का, तो हमको ऐसा कोई भी पॉइंट अगर मिल गया ई सच डैट सी ई इज इक्वल टू डी, तो एंगल सी ई डी का एंगल बाइसेक्टर सी डी का परपेंडिकुलर बाइसेक्टर हो जाएगा. By similarity, by congruency, we can show that if this is equal to this and this is equal to this, hence this must be right angle and this must be. Hence, to draw the perpendicular bisector of a given line segment CD, we just need one point such that CE is equal to ED. Here also, we just need one point such that, for example, E such that A is equal to B. Now for that, we know that the arc midpoint of AB, let's say E, EA is equal to EB. By definition, we are taking arc midpoint. And angle EDA is equal to angle EDB. Because equal arc subtend equal angle. And by drawing the angle bisector of angle ADB, we can get a line where E lies. And similarly, for 4th point, C, drawing the angle bisector of angle ACB with second line which passes to E. So taking the intersections of these lines, say L1 and L2, we can reach to E, and from E we can reach to the perpendicular bisectors, and by perpendicular bisectors we can reach to the center. So 4 points, we can draw the circumcenter of the circle passing through these 4 points. We have proved, and the motivation was going to perpendicular bisectors and using the properties of perpendicular bisectors. Now, in the case of 3, it is obvious that if given a triangle, we can draw its incenter by drawing the angle bisectors of each angle. It is obvious that we can draw incenter. So for 3 points given, we can draw its incenter, say I. And we have drawn AI and BI and CI respectively. And we can take the intersection of AI with the angle bisector of angle IBC. Let us say it X. Then the
ABBC से कंफ्यूजन हो सकता है कि वो भी बना हुआ है.
नहीं पेज पे चला जाता है. Now we are just हाँ अच्छा बात तो सही है. डायग्राम क्लमजी नहीं होना चाहिए पेपर के वक्त, तो उसके लिए लाइन नहीं ड्रॉ करनी चाहिए. अब फॉर एनी 3 पॉइंट्स वी कैन ड्रॉ इट्स इन सेंटर. वी हैव प्रूव्ड से आई एम, एंड वी कैन ड्रॉ बी आई. वी हैव प्रूव्ड दिस, बी आई, ए आई एंड सी आई respectively. And we also know this very famous property that ABC है and the x center opposite to A, say E है, and in center. These are four concyclic points. I, B, C, E are four concyclic points because this is interior angle bisector and exterior angle bisector, which are right angles, and similarly these are right angles, and two right angles concyclic हो गए B, I, C, E है. तो फिर इससे हमारे को ये मिल गया कि B, I, C, E है, ये concyclic points है. एंड बाय कि हमारे पास चार कॉन्साइक्लिक पॉइंट्स है तो हम उनका सेंटर ड्रॉ कर सकते हैं, एंड सेंटर ड्रॉ कर सकते हैं तो हेंस BC का परपेंडिकुलर बाइसेक्टर भी ड्रॉ कर सकते हैं बाय ड्रॉइंग द एंगल बाइसेक्टर ऑफ BOC. सो we just need one point beyond I on BI such that अगर हम इसका एंगल बाइसेक्टर बना लेंगे, मान ले x, तो फिर वो एक्सट्री एंगल बाइसेक्टर हो जाएगा एंगल AIB का, एंगल AIC का, AIX का इंटीरियर एंगल बाइसेक्टर एंगल AIB का एक्सटीरियर एंगल बाइसेक्टर हो जाएगा. और अगर एक्सटीरियर एंगल बाइसेक्टर मिल गया तो हमको EAE भी मिल जाएगा. आई तो ड्रॉ कर ही सकते हैं, वो हमने पहले ही प्रूफ कर दिया था कि 3 पॉइंट्स का इंसेंटर बना सकते हैं. तो हमको चार कॉन्साइक्लिक पॉइंट्स मिल गए, उससे हमको परपेंडिकुलर बाइसेक्टर्स मिल गए, परपेंडिकुलर बाइसेक्टर्स मिल गए तो सर्कमसेंटर मिल गया. तो अब हमको बस ऐसा एक x ढूंढना है ताकि हम इसका इंटीरियर एंगल बाइसेक्टर बना पाए, विच इज़ बियॉन्ड I on BI. एंड टू फाइंड दैट x वी कैन टेक द इंटरसेक्शन ऑफ एंगल ISE का इंटीरियर एंगल बाइसेक्टर और BI का जो कि ड्रॉन है. तो बियॉन्ड I भी होगा क्योंकि वो इंटीरियर एंगल बाइसेक्टर है, बियॉन्ड I भी होगा. तो फिर हम इसका इंटीरियर एंगल बाइसेक्टर बनेगा तो हमको एक एक्सटीरियर एंगल बाइसेक्टर मिल गया. एंड सिमिलरली हम एंगल ABI का बनाएगा तो हमको EB मिल गया, उससे हमको AI का परपेंडिकुलर बाइसेक्टर मिल गया, सिमिलरली BI का मिल गया. एंड A और BI का perpendicular bisectors meet on the arc midpoint of ABC. We can use that also, and by lemma 1 we can draw its circumsector. By this we can show that. अगर arc midpoint मिल गया तो we can draw the perpendicular bisector of AB. उससे भी कर सकते हैं कि perpendicular bisector of AB बना दिया, AC बना दिया, BC बना दिया, वो मीट कर जाएंगे वो पे. वैसे भी कर सकते हैं, दो मेथड्स हो जाएंगे उसके आगे, जैसे करना है कर देंगे. फिर जैसे कि आर्क मिड पॉइंट वाला पॉइंट दिख गया तो डायरेक्ट लेमा 1 आ जाएगा कि चार पॉइंट्स वन साइक्लिक हो गए. अगर आर्क मिड पॉइंट वाला नहीं दिखा है, बस ये दिखा है कि ये सर्कमसेंटर होगा AIB का, तो बस उससे परपेंडिकुलर बाइसेक्टर बना देंगे AB का, तो उससे आगे सॉल्व हो जाएगी चीज़ें.
This solution was that we had to go for perpendicular bisector, right? See, there were different ways by which we could have attacked circumcenter. One of the ways could have been that the central angle is 2A, 2B, 2C. Somehow we try to construct those angles and reach there. Right? Other thing could have been perpendicular bisector. So there are different approach that we could have taken, but perpendicular bisector through 4 points being cyclic, using that recursively in the question, very beautiful solution. Okay, so it's a very nice solution, and the way it is intended, it itself will take like 1.5 hours at least to construct and complete the question, even if we are thinking in the best possible way there, right? So very nice solution.